Today, we're going to peel back the layers on a manufacturing process you've probably never even heard of, but one whose incredible precision makes our modern world possible. Let's dive right into the hidden world of OD grinding.
Okay, so let me start with a quick question for you. What do you think a screaming F1 race car and a massive jet engine actually have in common? I mean, besides being just awesome feats of engineering. The real answer isn't about power or speed. It's about something way, way smaller.
It's this number, plus or minus 1/10,000th of an inch. To put that in perspective, that is thinner than a single human hair. And this isn't just some random measurement, it's the absolute standard for perfection, and it's the key to this whole story.
Which brings us right to the secret of speed. Because when you're talking about these incredibly high-stress machines, all the raw power in the world is totally useless if the parts can't hold themselves together with microscopic precision.
Just think about it for a second. In aerospace or a high-performance engine, you have critical parts spinning at unbelievable speeds. The tiniest imperfection, a deviation you couldn't even see, creates vibration. And that vibration leads to wear. And that wear eventually leads to, well, catastrophic failure. The margin for error is basically zero.
So how on earth do engineers get things that perfect? Well, the answer is a very specialized finishing process. Let's get into it in Section 2, a process of perfection.
You know, most metal parts start off being shaped by something called conventional turning. Think of it like a carving knife. It's great for quickly removing big chunks of material. But OD grinding, that's the final touch. It's more like a surgeon's scalpel. It's not about rough shaping. It's about removing microscopic layers to get that perfect dimension and a mirror-like surface finish.
And this is the tool that does it, the OD grinder. The OD, by the way, just stands for outside diameter. The whole idea is simple but brilliant. You spin a metal part, the workpiece, and then a very specific abrasive wheel makes contact with it. It gently removes just a tiny bit of material, perfecting its shape and size, especially on super-hardened metals that other tools just can't handle.
And believe me, this isn't some obscure thing. It's absolutely essential for parts that keep us safe. We're talking about things like the landing gear on an airplane, the heavy-duty hydraulic rods that lift massive loads, and yeah, those high-performance engine shafts in the race car we were just talking about. They all depend on the perfection of OD grinding.
Okay, so how does this machine actually pull off such mind-boggling precision? Let's take a look under the hood, so to speak, in Section 3, inside the grinder.
At its core, it really comes down to 3 basic steps. First, you mount the part securely and spin it at a very precise speed. Second, that abrasive wheel comes in and makes perfectly controlled contact, basically shaving off microscopic bits of metal. And third, and this part is absolutely crucial, you have to manage the heat. Even a tiny bit of heat can make the metal expand and throw the whole measurement off. And what's cool is how versatile this process is. There are different methods for different parts. You've got traverse grinding for long, straight shafts. Plunge grinding is used to cut specific shapes, like a groove. Then there's centerless grinding, which is this super fast method for making tons of identical parts. And of course, today we have CNC grinding, where computers automate the whole thing for incredibly complex parts, making sure every single one is perfect. But with this level of precision, the stakes are incredibly high. The mistakes are often totally invisible, but the consequences, they're not. Let's look at what happens when things go wrong in our next section, when precision fails. One of the biggest and scariest dangers is creating hidden stress. If you grind a part the wrong way, maybe with too much force or the wrong wheel, you can actually damage the metal structure just below the surface. So the part might look flawless, but you've secretly made it weak from the inside out. It could just fail unexpectedly when it's under load.
An even more common problem is something called surface burn. This is what happens when the grinding creates too much heat, and that heat literally changes the properties of the steel. You can sometimes see these little discolored marks on the surface, but the real danger isn't the color, it's that the thermal damage has created a weak spot that's now prone to cracking.
And this is exactly why you can't cut corners on the machine itself. This table spells it out. If your machine doesn't have great thermal stability, those precise measurements are going to drift as the machine warms up. Not enough spindle power, you're risking that surface burn we just talked about. Every single feature of the machine is directly tied to preventing these really costly and frankly dangerous failures.
Now, with all this talk about computers and fancy machines, you might be thinking the human expert is on their way out, but actually the exact opposite is true, which brings us to our final section, the expert's touch. You see, even the most advanced CNC grinder is still just a tool. It takes a highly skilled technician, a true craftsperson, to do the initial setup, to choose the perfect grinding wheel for that specific job, and to be there making constant checks to make sure everything is running perfectly. They are the guardians of that microscopic precision.
So really, the main takeaway is this. In these high-stakes industries, where performance and safety are everything, the skill of your team isn't just a nice-to-have. It's a strategic asset. A reliable, expert workforce is literally the difference between creating consistent quality and taking on constant risk.
OD grinding is just one of these amazing hidden processes that support so much of our technology. It operates on a scale that's too small for us to even see, but its impact is absolutely enormous. So that kind of leaves us with one final thought. What other invisible processes humming along just out of sight are making your world possible right now?